What if, thousands of years from now, scientists could tell exactly how long ago you lived? Or maybe, if you imagine, a futuristic alien species could predict exactly what year you were born in. Radiocarbon dating is used currently by archaeologists and geologists for this exact same purpose. They use radiocarbon dating to determine how long ago living organisms existed, and they do this using just one minuscule molecule, carbon. Radiocarbon dating is based on the comparison of radioactive carbon-14, which is unstable and begins to decay over thousands of years, compared to more stable forms of carbon in an organism, like carbon-12 or carbon-13. Using this comparison, scientists can accurately tell exactly what year living organisms lived and died in. So, how does radiocarbon dating work? Well, at its essence, carbon-14 is kind of like a clock that slowly ticks down over thousands of years and helps researchers estimate an organism's age. Carbon-14 is generated when cosmic rays, or dense rays of high-energy particles, pass through the Earth's atmosphere where they strike nitrogen-14 atoms, adding another neutron and creating carbon. All types of carbon, radioactive or not, combine with oxygen in Earth's atmosphere to create carbon dioxide. Plants then use carbon dioxide for metabolic processes like photosynthesis, where the carbon is embedded into the plant's tissues. There, the carbon dioxide is cycled through the food chain when plants are consumed by other organisms, which are then consumed by other organisms, and so forth. So, while organisms are alive, they'll contain around the same amount of carbon as their environment. But when they die, the intake of all carbon stops, and the decay process of the carbon-14 inside their tissue begins. Carbon-14 will slowly decay back into the stable form of nitrogen-14, which can take thousands of years. We now know that carbon-14 decays exponentially and has a half-life of around 5,730 years. So the original amount of carbon in an organism will halve after 5,730 years and become a quarter of its original amount after 11,000 years, and so forth. Scientists then compare the levels of carbon-12 and carbon-13 to the amount of carbon-14 left in the organism, using the more stable forms of carbon as a baseline to estimate how much time has passed since the carbon-14 has started to decay. However, radiocarbon dating still has its limits. For example, it can only be used for organisms originating less than 50,000 years ago. Any more than that, and the levels of carbon-14 in the tissue will have depleted to undetectable levels. Now that you know how radiocarbon dating works, I hope that you'll continue to explore the ever-growing history of the Earth and the animals that walked on it.